Mixed numbers to improper fractions, part 2. Before we can start converting, I need to explain to you what a mixed number is and then what an improper fraction is. What I just taught you was called a proper fraction, a regular fraction, no funny business, okay? But now we're moving into more advanced things, all right? We're moving on up in the world. We got mixed numbers and improper fractions. So mixed numbers, the reason why they're called a mixed number is because they are a mix between a whole number and a fraction. It's a combo. It's mixed, okay? A whole number and a fraction, all right? So I'm going to start with the mixed number 1 and, I'll do 1 and 2/3. So 1 and 2/3. If I hear the word and, that tells me that I'm going to be dealing with a fraction or a decimal, and I hear the number 1 before I say and, so that tells me it's a whole number. So I need to make sure I do a big number 1 because it's a whole number, and I said 1 and 2/3. 1 and 2/3. Again, it's called a mixed number because it's a mix between a big whole number and a fraction. Do you see? Fractions are less than a whole, that's why it's smaller. Anyways, I need to now take this mixed number and be able to represent it with a model. Well, first of all, in a mixed number, is that going to be more than or less than a whole? It's going to be more than a whole because I have I have more than a whole here. So because I have more than a whole, I'm going to need more than just one whole fraction model. Would you agree? Cool. So I know I'm going to have at least how many fractions? At least 2, right? At least, or fraction models, at least 2. Okay. So I'm going to start by drawing 2 fraction bars. 2 fraction models. 1, 2. 1 and 2/3. Alright, so I've got my 2 models drawn here. I'm going to look at the fraction part. I see the fraction, I've got 2/3. I know this 3 down here is going to be my denominator. And we just learned that the denominator is the total number of parts you break your model into. So because my denominator here is a 3, I need to break my model here into 3 pieces. Not just one model, both models, because I'm dealing with a mixed number here. So I'm going to split it into 3 pieces. Boom. Alright, so I've got my stuff drawn, 1 and 2/3. This big 1 tells me that I'm going to have one whole entire thing shaded in. So I'm going to go ahead and shade one whole fraction model in. Alright, now 2/3, alright. To represent 2/3, I need to understand this model is broken into 3 pieces. So that tells me that each one of these pieces is worth 1/3. This is worth 1 out of 3 pieces. 1 out of 3 pieces. 1 out of 3 pieces, okay? For my mixed number, I need to be able to represent 2/3. So that tells me I need to shade in 2 pieces. Good. 1, 2. This part isn't shaded in, I was just showing you what it represents. So here I've got the number 1 and 2/3. That is how I say it, and this is how you read it. 1 and 2/3. This right here is worth 1 whole. This piece down here is worth 2/3. That is why it's a mixed number and it's written like this. So this is mixed numbers. Now, just so you know, mixed numbers and improper fractions, okay, they can represent the same thing. So I'm going to move on over here, and I'm going to give you a improper fraction. Chris, could you check to make sure I'm still in frame when I'm right here? Chris? Would you be able to check to see if I'm in frame right here?
You are.
Okay. Alright, improper fractions. Hey, pay attention, eyes up here. Alright, and by the way, you shouldn't be writing any of this down, you should just be watching me. So the next thing I'm going to do is going to be an improper fraction. The reason why it's called an improper fraction is because it doesn't make sense. We know fractions are less than a whole, but I'm about to show you what one looks like. When we're dealing with regular fractions, we know that the numerator should always be less than a denominator. But in this improper fraction, my numerator is actually bigger than my denominator. And that tells me, okay, that tells me that I'm dealing with an improper fraction. It's not proper, it's all messed up. Now, when we're dealing with improper fractions, you need to know too that's always going to be more than a whole. Because the 3 down there represents how many pieces are in my whole. So if the numerator is the number of shaded in parts, and I only got 3 parts, but I got more shaded in, that tells me I'm going to need more than just one fraction model. So I'm going to now draw 2 fraction models. Will I need more? Maybe, but we're going to start with 2. 1, 2. Nothing changes about the denominator and then proper fraction. It still means the same thing. My model needs to be split up into 3 pieces. Each model will be split up into 3 pieces. Now, here's my question right now. All right. If these are split up into 3 pieces, I know that each one of those pieces is worth what? 1/3. We did it down here. So I'm going to put 1/3. 1/3, 1/3, right? This is, 3/3, whatever. 1/3, 1/3, right? I'm just representing what each one of my fraction pieces is worth. So now I need to be able to model my improper fraction. The numerator has a 5. That tells us how many pieces I need to shade in. So I'm going to shade in 5 pieces. I'm going to start at the first one. 1, 2, 3. Well, that's not 5 yet. I got to keep going. 4 and 5. I've got 5/3 shaded in. Now what we're dealing with here is something special. We got more than a whole. Improper fractions and mixed numbers both represent more than a whole. Okay? Do you see right here how they're the same? They're just written in different ways. Kind of like when we're doing fractions and decimals. Fractions can be written as decimals. Decimals can be written as fractions. In this world, mixed numbers can be written as improper fractions, and improper fractions can be written as mixed numbers. Here, I showed you. I got 1 whole piece shaded in plus 2/3. If I break it down, I'm about to count how many actual little 1/3 pieces I have shaded in. And that's 1, 2, 3, 4, 5. 5/3. It's just written in a fancy way. If I come over here to my improper fractions, would you agree this right here is still 1 whole? 1 whole. Yes. And if I'm dealing with just this model down here, it represents 2/3. This together, if I write it, is 3/3, right? 3 1/3, 2/3. Right here, I've got 5/3. Same, but different, just like fractions and decimals. When you're dealing with these two things, you're going to have to be willing to draw these fraction models. That's just how it is. You have to draw them sometimes because that's the only way in your brain you can really visualize what's happening. So mixed numbers and here's your takeaways. Mixed numbers and improper fractions are the same, right? They can be written in either way. We represent them with more than just one fraction model because mixed numbers and improper fractions are more than a whole. And then always remember what the worth of each one of these little tiny pieces of your fraction bar are worth. Okay? All right. Bye.
Good?
Yeah. I